This section is on rational and irrational numbers. I'm going to follow right along with section 6.6 in the book because I think that example example 1 on page 283 is a really good example here for you to follow along. So this is page 283, example number 1. The concept of rational versus irrational numbers is this, and it usually manifests itself when we talk about square roots. Well, that's why we're talking about that in this section. So if you look at example A, and we have the fraction 37 over 16, and we do this long division and we get 2.3125. Or we have the fraction 19 over 22. The question is, are either of these rational or irrational? The answer to that is found down here or over here on the right. In the left hand in the yellow, what we find out is that if we divide 37 by 16, that eventually, when we get down to this point down here, we find that we have zero remainder, if you remember from your long division days in grade school. So we have zero remainder, which means that 37 over 16 can be defined or rewritten, in other words, by the decimal 2.3125. And the next one here is 0, 0, 0. So in effect, we have a repeating here, but it's 0. The other option is that on the right hand, that if we look at the fraction 19 over 22, we can see that we will have 0.86363. And if you look at here, here, and here, and the blue here, that these are all recurring remainders, as it states in the book. So these two types of fractional expressions are both known as rational numbers because they can be expressed as the ratio quotient of two integers. Now, if you look in the gray in the book, it has a good definition here. Every real number has a decimal representation, and every decimal represents a real number. So that means that we either end up getting a zero remainder or repeating. Now I'm going to go on in the next section. I'm going to pause this and get a clean screen, and we're going to go on for another section here and figure out how to do long division here to determine and go the other way if we have a decimal to determine what that fraction is. I've turned the page and I've gone to example 2. And what we're going to be doing here is really the opposite here. If you look along on page 284 with me, the idea is if you look at example 2 and 3, if we have a number, how do we find the fraction? Now, the easy one is, this is 2.571. Well, that's the same thing as saying 2 and 571 over 1,000, because that's 3 decimal spots here. So that's pretty easy. And I won't write this, but the second one is 0.0036. Well, that's 36 divided by 10,000. Those are kind of the easy ones here. Woo! So we'll erase this, and we can fill it back in if we want to. We can now go to example 3 here and look at perhaps what is a little bit more difficult. In this, what we want to do is introduce to you how to do this division. So example 3a says, look, we have the number 0.327, and we have this notation of a bar over here, and that bar means that's repeating those two numbers. So that means that number is actually 0.32272727. You get the point. That's repeating. So the question is, what's the fraction? What is this fraction that results in that repeating decimal? Here is the technique. We're going to create a number n. And n is determined by how many repeating decimals we have. So n is equal to 0.327. Now, 100n is the number of decimals that repeats. So 100n is equal to 327 times 100, or 32.727. Correct? Now, subtract from that n, minus n, so to speak, and we get 0.327, and we're left with 99n is equal to 32.4. Now, what we're going to do with that is, so follow this. Let me repeat this again. Here is this fraction, or excuse me, this number. We want to know what fraction results in that decimal. That's what we're doing here. We look at n as being this number repeating. We note how many repeating numbers, and that is 2. We take n and multiply it by 100 because that is 2 decimal points. So 100n is 0.327, and remember that this repeats 2727. Those are the numbers, not 3, that are repeating. So this becomes 32.727, etc. And n remains as 0.327. Subtract these two. 100 minus n, right here, is 99 n here. 32.727 minus 3.327 is 32.4. That fraction, therefore, is 32.4 over 99. Now, that represents this fraction. Your next job is to simplify that, which is, this is 324 over 990. And since the book has done the hard work here, that is 18 over 55. I'm running out of space, but that's okay. So here's where we went. We went from an expression over here and wanting to know what fraction leads to that decimal. And that is it right there. If you divide 18 by 55, you get 0.327.